Question number 5 is our probability question where it's using the normal standard variable z. Remember, I can link z with x by x minus the mean over the standard deviation. And we know that x has a mean of 5.3 and a standard deviation of 0.2. So if I want the probability that x is less than 4.9, so there is my 4.9, and that is the probability that x is less than 4.9. That's the same as z being bigger than. So how many standard deviations do we have here? So standard deviation is 0.2. So 5.1 would be one standard deviation. That's going to be two standard deviations. So 4.9 lines up with -2. And I'm looking for z bigger than a. Then a is going to be over here at 2. And that probability will be the same as z being bigger than 2. Now, if I could use this just to double check that z is going to equal 4.9 minus the mean, 5.3 over 0.2, 0.4 over 0.2, but that's -2, and that corresponds to my 4.9. But of course, they've flipped it around because I want z bigger than, so a equals 2 is my answer to part 1, or part A. Part B is still to do with the same scores for z, for x, because A and B are both indented in, and this is the paragraph that both of them refer to. So given that the probability of z being bigger than 1 is equal to k, so if I do my z score, and that is 0, bigger than 1 is going to be k. So that's k there. And we got the probability that x is bigger than 5.1 given that x is less than 5.3. So that's going to equal the probability that x is bigger than 5.1 intersect x less than 5.3 over the probability that x is less than 5.3. Well, 5.3 is the mean. Therefore, the probability that x is less than 5.3 is a half. And we want the probability of, I want to be bigger than 5.1, or I want to be less than 5.3. So I want in between. So 5.1. Okay, so I'm interested in the value of 5.1. So the z score for 5.1 minus 5.3 over 0.2 is -0.2 over 0.2. Well, that's a value of -1. So if I was to compare my x score of 5.3 x 5.1, I want the area in between here. And I know that z being bigger than 1 is k, which means that over here I've got k, and that will be 5.5, 1 standard deviation. So this is k here. So I know that that all the way back there is a half. So this thing in here is a half minus k. So 0.5 minus k over 0.5 can be my answer, acceptable answer in terms of k. Or I can say that I have 0.5 on 0.5 minus k on 0.5, which is 1 minus k under half, which is 1 minus 2k. This is an acceptable answer. This is an acceptable answer to our conditional probability in terms